guys, it is getting to be lunch, so if it gets a little loud in here, sorry, I just had a whole lot of stuff to catch up with this morning and I had a meeting, so here we go, a lunchtime review. So I guess what I'm going to do is I'll go through each section and I'll do one problem from each section. If you, maybe I'll do a couple. I'll just take a look and see. If I don't go over a problem that you really want me to go over, please let me know. Send me an email. Even if I'm doing this today on May 1st and you end up, watching this video on May 10th, please ask me to go over a problem. I have no problems whatsoever going over an extra problem for you and giving it to you. Whether we just do it for you or we give it to the whole class or whatever. It's perfectly fine. Perfectly fine. I'm here to help you get through all this stuff. All right, so series review. I need to also let you guys know that we don't need to do numbers 1 through 4. I will I'll put that on, although, it's not that you can't do, oh, no, wait, you can do. All right, just kidding. Haha, I didn't look at this before I got started. I should have. You can do numbers 1 through 4. Yay, write the first 4 terms and then find the sum of the geometric series, blah, blah, blah. Let's go ahead and just look at number 1. Number 4 we didn't do, so if you are struggling with number 4, we'll go over that one as well. There is one like that on the test, and that way you can refer back to number 4 when you do the one on the test. So we'll do numbers 1 and number 4. Sorry, I should have prepared more before I got started with this. All right, so number 1. So your sum is 3 to the n over pi to the n. And so to get your first term, you're going to plug in a 1. Oh, nope, look at the bottom. It says n is equal to 0. So the first term you're going to plug in is a 0. Well, if you plug in a 0, 3 to the 0 is 1, and pi to the 0 is also 1. So your first term is going to be 1. Then when you plug in a 1, you'll get 3 over pi. When you plug in a 2, you'll get 9 over pi squared. When you plug in a 3, you'll get 27 over pi cubed. Okay? And you're going on and on and on and on. All right, the next thing, they want you to find the sum. Well, in order to find the sum, it means that it has to converge. And in order for it to converge, you've got to find your r, and your r has to be less than 1. Well, look at your numerator. You started with 1, and you end up with 3, then 9, then 27. So you're multiplying the numerator by 3. The denominator, you're multiplying by pi. So 3 over pi is your r. Now, you could use a calculator, but you don't have to. You know that pi is 3.14159, blah, 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 blah. So it's bigger than your 3, which means you do have a fraction that's less than 1. So that means you can find the sum. Now, on the test, you are not going to have to find the sum. I'm looking over here. 1, 2, 2, 2. So you don't have to worry about the sum stuff, although let's say we're on the AP test and they want you to find the sum. Remember, you've got your formula of a over 1 minus r. So a is the first term, that's going to be 1. R is your 3 over pi, so 1 minus 3 over pi. You put that in your calculator and you get 22.188. Please remember your 3 decimal places. You got to make sure you got your 3 decimal places, even on this AP test. Those types of things aren't going to change. All right, let's go ahead and look at number 4. Now with number 4, you just have 2 series, okay? Now what you can do is you can break those series up. So you can have series 1, which is going to be 2 over 3 to the n, and then you can have series 2, which is 3 over 4 to the n minus 1. So you're going to break it up into 2 different series. You're going to find the r for each one of them, and then you're going to find the sum of each one of them. In order to get the actual n sum, you just have to add them up. So you break it up to make it look a whole lot easier. And in the notes, I went ahead and I did that as well, series 1 and series 2. So if you're in series 1, and this says n equals 0, so you're plugging in a 0 down here. So that's just going to be 2 over 1, so that's a 2. Your second term would be 2 over 3. Oh, we're plugging in a 1, so 2 over 3. Plug in a 2, that's 2 over 9. plug in a 3, that's 2 over 27. So your R is then going to be a 1 over a 3, because you're not multiplying anything in the numerator, you're just multiplying by 1 because it stays at 2. And you multiply 1 by 3, 3 by 3 is 9, 9 by 3 is 27. Your R is equal to 1/3. So your sum is then 2 over 1 minus 1/3, which equals 3. Then you do the exact same thing with this one. So the first thing you're going to do is you're going to plug in a 0. Well, 4 to the negative 1, that's going to bring it to the top as 4 to the 1. So 3 times 4 is 12. Then you plug in a 1, so that's 4 to the 0, so that just makes the second term 3. Then you plug in a 3, which is going to make the bottom, wait a minute, 0, 1, we're going to plug in a 2. That'll make the bottom 1, so you get 3 over 4. Then 3 over 4 squared. So your R. Look at your numerator. You're starting at 3, or at 12. Then you get down to 3, and then it's always a 3 after that. So that one's kind of confusing. Take a look at that 3. If it's always a 3 after that, it's going to be a 1 in the numerator. And then in denominator, look, weird. You added 12, and then there was nothing, and then there was a 4, then there was a 4 squared. Well, look at what happens if you multiply by 1/4. If you multiply 12 by 1/4, you're really dividing by 4, which gives you 3. If you divide 3 by 4, you get 3/4. If you divide 3/4 by 4, you get 3/4 squared, 3 over 4 squared. So your R is equal to 1/4. Also put, take a look at your exponent there. So your sum is going to be 12 over 1 minus 1/4, which will give you 16. So to get the sum of both of them together, you just add those together. 3 plus 16 is equal to 19. So that's how you're going to deal with number 4. All right. 5, 6, and 7 says use the divergence test to determine if the series diverges. The test is going to be set up exactly like this review. I mean, this test is supposed to be nice and easy. It's just supposed to help you to practice and make sure that you understand all the different pieces and all the different tests. Now, again, remember, you can use your notes on this test because you can use your notes on the AP exam. So that's going to help you with all of these tests that you have to do. Now, just because the review is set up like use the divergence test, boom, it looks just like that in the test. I tell you, number 1, 2, and 3 look like number 1, 2, 3, 4 in your series review. Number 4, 5, and 6 look like 5, 6, and 7 on your series review. Really and truly what I do is I just don't give you as many of them. I make the test a little bit shorter. So the divergence test, that's the nth term test. Nth term test just means we're going to do the limit. And when we do the limit, if it equals a number, then it diverges. If it equals 0, then your test fails and you can't do it. So let's take a look at number 5. Now, the one thing that I'm going to be super particular about on this test is that you have to show your work, which means you can't say 1/3 diverges, because I'm going to say 1/3 what? You have to be particular. You need to show me that you're taking the limit as n approaches infinity of n plus 1 over 3n minus 4. And then you can tell me that that equals 1/3, and so this thing diverges. Now, it's going to diverge by the nth term test. Or you can say by the divergence test. That's fine as well. Let's look at number 6. Again, the limit as n approaches infinity. Now go ahead and write the entire equation down. Don't cut your corners here, not on test day. On your homework, if you want to cut your corners and you just want to go ahead and, tell me what the answer is, kind of like we did with example 10, that's fine. But this is test day, which means we want to be particular and we want to practice what we're going to do for the AP test. So you've got n squared on the top, n cubed on the bottom. Bigger on bottom is equal to 0, so your test fails. Okay? All right, you would do the same for number 7. You get 2/3, which means it diverges. So let's move on to the next one. All right, we got the P-series test. 11, 12, and 13. Oh, no, just kidding. 8, 9, and 10. So the P-series, you want to determine the P, and then you want to determine if it diverges or converges. This is the easiest section. This is the one I like the most. We can just sort of talk about this. Number 8, you've got 1 over the square root of n. So you need to find that exponent. So you need to rewrite this as an exponent. Well, that's n to the 1/2. So your P is equal to 1/2. 1/2 is smaller than 1, so it will diverge. Okay. Number 9, we've got 1 over the square root of n cubed. So that's going to be 1 over n to the 3/2, where P is equal to 3/2. 3/2 is larger than 1, so that means this thing is going to converge. And then number 10, you've got 1 over n squared. So P is equal to 2, and that is bigger than 1, so it will also converge. So that is the P-series. You don't have to write the limit. You don't have to do anything like that. The P-series one is going to be the easy one that you have to do. All right, the next section, we've got the integral test. Now, the integral test is the one that's not everybody's favorite. You're going to have 2 of them on the test. Okay, you're going to have to do 2 integral tests on the test. So, let me see which one looks ugliest. Oh, maybe we go ahead and do number 13, huh? Number 11 we did in the notes already. That was a harmonic one. I think that was the first one we did in the notes. Number 12 looks okay as well. Use your U-Substitution. You're going to get your integration to be ln. So let's go ahead and do number 13. All right, now again, with the integral test, I want you to be particular with what you're doing. Now, in the integral test, you needed to make sure that this thing was positive and decreasing. So if you were on an AP test, they would expect you to show that it was positive and decreasing. So how do you do that? Well, if you're looking at number 13, here's your little question here. N equals 2 to infinity. Well, if you find the first couple of terms, that's how you can prove that it's positive and decreasing. So the first thing you're going to do is plug in a 2. Okay? So that's a positive number. There's nothing negative there. Your second one is when you plug in a 3. Well, that's a positive number, and it's getting bigger in the bottom, which means it's getting smaller and smaller and smaller. And then you could probably do one more. I would say if you do 3 or 4 of these things, it's going to show that it's positive and decreasing. So since it's positive and decreasing, we can now go ahead and we can move on to the next thing. This thing. There we go. That's a little more in focus. So what you're going to do is you're going to do the integration from 2 to infinity of 1 over n times ln n quantity squared dn. Now, when we're doing the limit to infinity, the infinity is in the b spot. So you've got the limit as b approaches infinity of the integration from 2 to b of 1 over n times ln n quantity squared. Okay? Now, notice that I'm doing all of my work. I'm writing down the b, I'm writing down everything. Now, the U-substitution stuff you can kind of do on your own. I'm going to make u equal to ln of n. So du over dn is equal to 1 over n. So I end up integrating 1 over n u squared times n du. So those go away. Which gives me the integration of u to the negative 2 du. So I end up with u to the negative 1 over negative 1. So the limit as b approaches infinity. Notice I haven't let that limit go away. I'm writing that limit yet again. I'm going to write the limit as b approaches infinity of negative 1 over u to the negative 1. So ln of n. And I want to evaluate that from 2 to b. Now, guess what? I have to write the limit again. So I'm writing the limit as b approaches infinity, and I'm going to plug in the b first, negative 1 of ln of b minus, now I'm going to plug in the 2. Okay? Now, we have to evaluate the limit. When you plug infinity into the denominator here, you got ln of infinity, which means that's going to infinity. Well, if your denominator is going to infinity, that means this thing right here is going to 0. Okay? Because remember, you're getting one piece of pizza and you cut it into a billion different pieces. So you're getting like string. Which means this is some sort of a number. ln of 2, I don't know what it is, but it's some sort of a number, which means my answer is 1 over ln of 2. Now, because it equaled a number and not infinity, this thing is going to converge by the integral test. Okay? So, just be very careful. You'll have 2 of these on the exam. Just be very careful to write down this limit every time. There were a few of you that turned in that first test that did not write that word limit. Make sure you're writing the word limit down. All right, the next one. You've got the limit comparison test. Now, notice I took off the direct comparison test. You won't see the direct comparison test on my actual test. Now, does that mean that it's not going to show up in the AP? Of course not. We don't know what they're putting on that AP test. So make sure you have all of your information when you're ready to take that AP test. But for my test, I'm going straight to limit comparison test. Let me see, which one? So number 14, you're going to compare that to 1 over n, which diverges. In 15, you're going to compare that to 1 over n squared, which is a p term, and that one's going to converge. And then in number 16, you're going to compare that to a geometric series of 5 over 4 to the n. I guess I could take a look at number 14 and number 16 as I'm looking at your test. Well, yeah, we'll take a look at number 14 and number 16. All right, number 14. This one is like n squared over n cubed, which is really just 1 over n. Make sure you reduce those things. Okay? Don't compare it to that, because what the heck is that? That's not anything. You want to reduce it to make it down to something that's a p series. Okay, where p equals 1. Now, when p equals 1, we know that this is harmonic, and that's going to diverge. Now, once you do that, you know, like if this were multiple choice, that this thing diverges. But this test isn't multiple choice, and neither will your AP test be. So what we have to do is we have to show our work. We have to do the limit as n approaches infinity of our original function, 2n squared plus 5 over 3n cubed minus 5n squared plus 2, divided by what we think it's like. But remember, divided by means the same as multiplying by the reciprocal. So you're going to multiply by the reciprocal of your harmonic, and you end up with 2n cubed and 3n cubed. So your answer is 2/3. Now remember, as long as this thing equals a number, then it's going to go ahead and do whatever you think that it did because of whatever it was like. So this will diverge by the limit comparison test. Now again, you can't just leave it right here. You have to go all the way down here and you have to show by the proof that it is going to diverge. Because it equaled 2/3, it will diverge by the limit comparison test. Now let's go ahead and look at number 16. Because with number 16, you have 5 to the n over 4 to the n plus 3. So that one's not a p series. But it could be like the geometric thing of 5 over 4 to the n, or 5 to the n over 4 to the n. Now, in that case, if you were doing it to your geometric, type thing, you're going to get that r is equal to 5 over n. Well, and you could do that by finding the first couple of terms, or you could just remember, oh, hey, yeah, that's always been our r raised to the n. That's bigger than 1. And so if it's bigger than 1, it's not going to converge to get a sum. It's going to diverge. So we then have to do the limit comparison test. The limit, as n approaches infinity, of our original function times the flip of our other function. So that would be 4 over n on the top and 5 over n on the bottom. Now, look, 5n over 5n cancels. 4n over 4n cancels. It doesn't cancel to go away. It cancels to equal 1. So this thing is just equal to 1. Well, 1 is a number. And so that will mean that this will diverge by the limit comparison test. Okay? So that helps with number 16. All right, ratio test is next, and I'm looking at the test. You've got 2 examples of the ratio test, and they both look very similar to the ones we're looking at here. I'm going to go ahead and do number 18. It just looks harder than number 17, so I'll give number 18 a shot. Now, when you're doing the ratio test, the first thing you need to do is figure out what the new equation looks like when you do n plus 1. So if you have n plus 1 plus 3, okay, let's look at our original. Our original is n plus 3 factorial over n times 4 to the n. So if I do this one and I add 1, if I have n plus 1 plus 3, that's just going to be n plus 4 factorial. This one will be an n plus 1. And this will be a 4 to the n plus 1. Now, when you're doing your limit, okay, remember, you've got to put the plus 1 on top. So the one that is bigger has to go on top. So that means that this one, n plus 4 factorial, goes on top. And you're going to keep change flip with the bottom, or the original. Okay. Now, we need to expand some of these things out. Now, n plus 4 factorial over n plus 3 factorial. Which one's bigger? N plus 4 is bigger because plus 4 is bigger than plus 3. So, I'll have n plus 4 times n plus 3 factorial. Because remember, factorial goes down by 1 each time. Once you've matched this one to cancel it, then you can just be done. There's nothing we can do to simplify n plus 1. But 4 to the n plus 1 can break down to be 4 to the n times 4 to the 1. N, 4 to the n plus 3 factorial. So, your n plus 3 factorials are gone, your 4 to the n's are gone. Please don't forget to write the word limit. We've got, left up here, we've got an n and an n plus 4 on top, and on the bottom we've got a 4 and an n plus 1 on the bottom. Alright, you've got n squared on the top and you've got n on the bottom. So since you've got bigger on top, your bottom, it's going to infinity. So if this thing goes to infinity, you are going to diverge because it's greater than 1. Okay, if it's greater than 1, it diverges. Now, let's see. My ratio tests were number 17 and 18. Both of them went to infinity, so both of them will diverge. Not necessarily the case. So just make sure that you're using your notes and making sure you know what it is that you have to do. All right. Number 19 or 20, the root test. The root test is so easy. But let's go ahead and look at number 20 though, because 20 looks a little interesting. For number 19, you just make sure you're writing the word limit and you're doing the, I didn't actually write it all down. All right, let me write it down because in the notes I didn't write it all down. You're doing the limit as n approaches infinity of the nth root of 2n plus 1 over 3n minus 4 to the n. So this is what you get. and then it's going to converge because it's less than 1. All right, so let's look at number 20. What on earth are we doing with number 20, and how did I get n to the 1 over n in the numerator and over 4, and what did I do there? All right, well, let's just get started. You've got the limit as n approaches infinity of the nth root of n over 4 to the n. Well, that's going to look like this. You can separate that into the nth root of n and the nth root of 4 to the n. Well, this is just going to become n to the 1 over n. And this is just going to be a 4. So that's how I got it. All right, well, so let's take a look at what's happening here. If I plug in infinity, the first place I'm going to plug it is to this exponent. Now I can figure out what the exponent is before I can figure out what the number is. Well, if you have 1 over infinity, this whole thing is going to 0. Well, what happens to any number if it's being raised to 0? It goes to 1. Anything raised to 0 is equal to 1. Even infinity raised to the 0 is going to equal 1. And then the denominator is just 4. So that's how I got the 1/4 to know that this thing was going to converge. Okay? I hope that helps. All right. The last thing, Taylor series to a 4th degree for the following functions. Let me see which one I think is the most difficult. It's pretty self-explanatory there. Maybe we go ahead and we do we'll do number 23. Now with number 22, the thing you've got to be careful, and with number 21 for that matter, you've got to be careful with the chain rule with both of those things. So when you're doing the derivative over and over and over again, make sure that you keep, for 21, you keep multiplying by an extra 2. And then for 22, you keep multiplying by an extra 2 pi. And I've shown that in the notes. And if you need to see 21 and 22, please just shoot me a quick email or a note, and I'll be happy to go over it with you. So now let's go ahead and just do number 23. All right, so when you're doing this, the first thing you got to do is you got to have your function, and then where you're centered. And we're centering a equals 3 right here for number 23. And my function is 1 over x squared. And I went ahead and I wanted to save some lines, so I just went ahead and stopped. This is my function, then first derivative, second derivative, third derivative, and I guess I have to go to the fourth derivative. All right, now I don't take a derivative this way. I take a derivative when it's x to the negative 2. So that's negative 2x to the negative 3. So that's negative 2 over x cubed, because I'm going to be plugging in a 3. So I need this to be in the denominator so that I know what it is that the fraction will be. But I needed it to be up in the numerator in order to take the next derivative. So I've got a positive 6x to the negative 4. So 6 over x to the 4th. And then I multiply again, I got negative 24x to the negative 5. So negative 24 over x to the 5th. And then I multiply again, and I have 120x to the negative 6th. Oops. When I take it to the bottom, it'd be positive. Now I'm plugging in a 3. Now I used a calculator at this point. Not when I squared it, but when I got up to the 4th, 5th, and 6th. So when I plugged 3 in here, I got negative 2 over 27. Then when I plugged in 3 here, I got 6 over 81. Now, I did not at all worry about simplifying these things. I'm not wasting my time. If you are on the AP test, you already know and probably are a little nervous about the timing that you've got. And because you don't have a whole lot of time, don't stress with doing simplification. Don't simplify stuff. You just need to have an equals whatever, and then once you get the equals whatever, don't worry about simplifying. They're looking for process, not can you simplify a number. Now, remember, this one's going to be at 1. Then we've got an x minus a, so that's x minus 3. Don't forget that it's x minus a. Don't just make it x. Then you have x minus a squared over 2 factorial. X minus a cubed over 3 factorial. X minus a to the 4th over 4 factorial. And now you just write it down. So you've got 1/9 minus 2 over 27 times x minus 3 plus 6 over 81 times 2 factorial times x minus 3 squared minus 24 over 243 times 3 factorial times x minus 3 cubed. And then plus 120 over 729 4 times 4 factorial times x minus 3 to the 4th. Okay? Now, could these things be reduced? Could these numbers be multiplied? Of course they could. Don't bother. Please do not bother. You don't need to bother on the test. You also do not need to bother on the AP exam. Okay? Now, there on the test is going to be an extra credit. Don't do it. There's also going to be a number 21 with radiance of convergence. Don't do it either. The AP has kind of simplified some of the work that we have to do just to make sure that we get through everything in order to take the AP test. So we will not worry about those problems. So, have a great day, and I will talk to you guys soon.